morning, Group B students. Today we're going to go ahead and start Chapter 2, Section 2.1a. Now, I know you guys have not taken all of the Chapter 1, Part 2 tests, but to keep up with Group A, we've got to go ahead and get you started on Chapter 2. And it's not really difficult. It's not a whole lot of information, but it is stuff that's important to know for trigonometry and pre-calculus. And it's going to be helpful if you have notebook paper out and be ready to take some notes. You can either follow along with me using my notes on Canvas, or you can just take your own notes. So today, we're going to talk a lot more in this chapter about quadratic functions. Recall from the last chapter, what was the parent function used for this graph? Right, it is y equals x squared. That was the parent function we talked about in the last chapter. And then some real-world examples, just a couple to kind of connect what we're doing today. If any of you are Mario fans out there, that one is an example of a quadratic function, the way that Mario jumped to get the little coins. And then also if you play basketball, the quadratic function is modeled when you shoot a basketball into the hoop. So those are a couple of real-world examples of quadratic functions. Now we're going to analyze them a little bit more, talking about key pieces of them. One way that you could see a quadratic written is known as vertex form. And that's f of x, which means the same thing as y, equals a x minus h squared plus k. That's called vertex form, with a, x, h, and k. The vertex of a parabola is the point where the graph comes together at, and that vertex is h comma k, which is why this is called vertex form, because here's the h and here's our k. So whatever numbers are there, that tells us immediately what our vertex is. The axis of symmetry, basically what it is it's the dividing line of a parabola. Divides it right down the middle. And it's a line, x equals, because it's a vertical line, whatever your h is. So whatever the h value of your vertex is, that's what the equation of the axis of symmetry is. Something else to point out about the vertex, this h is always the opposite. Because it's on the inside of the function, it is always the opposite of what it appears to be in the parentheses. Over the next few slides, we're going to analyze different functions in vertex form and describe the key pieces of the function. It says for the given function, find all these pieces. G of x equals x plus 2 squared minus 1. Because it's got parentheses, we know this is in vertex form, which is the form that we're learning about today. Let's first do the direction of opening. Remember when we talked about parent functions, if that was a negative in the front, then it went over the x-axis. So if there's a negative, it points down because it's a reflection. If A is positive, then it points up. Remember, this is A, H, and that's K. So because there's a positive in the front, my direction of my parabola is up. The vertex, remember vertex form is the H and the K. The H is always the opposite because it's on the inside. And so instead of 2, it's going to be negative 2. And then the K is negative 1, so it's the same, negative 1. Let's go do the x-intercepts. X-intercept, how did we find those before in chapter R? Right, we found them by setting y equal to 0. So I'm going to set my equation equal to 0 and go solve for x. Squared minus 1. Add 1 to both sides. So I have 1 equals x plus 2 squared. To undo something that's squared, I'm going to take the square root of both sides. Plus or minus 1, right? When you take a square root, remember you get the positive and the negative version out. Plus 2. And solve for x by subtracting 2 to both sides. So I have negative 1 minus 2, which makes negative 3. There's one of them. And I have positive 1 minus 2, which makes negative 1. So there's the other x value. So our x-intercepts are at negative 3, 0, and negative 1, 0. All I did is plug in 0 for the y and solve for x. Next one, to get the y-intercept, I'm going to set x equal to 0 and plug that in. So y equals 0 plus 2 squared minus 1. 0 plus 2 is 2. 2 squared is 4, minus 1 is 3. So I just plugged in 0 for the x, 0, and got 3 out for the y. So 0, 3 is my ordered pair for the y-intercept. Now using all these pieces, I'm going to go sketch my function. So off to the side here, we're just sketching it using all the pieces we just found. We know it opens up because it was a positive in the front. We also know the vertex is -2, -1, so I can go label where that is, right there. The x-intercepts, we're at -3, 0, and -1, 0. So here's -3, here's -1. The y-intercept was at 0, 3, right here. And now I'm going to connect all those pieces together to make my function. So the y-intercept, the x, and then connect them all together. And it's pointing up because the positive was in the front. And that's my graph. Next pieces I can find, axis of symmetry. Remember, that's the vertical line that divides the graph in half, which is at x equals whatever h was, which was -2. State the min or max values. It has a min because it has a low value, and it's at the y value, which is at -1. The domain and range, we should be really good at that by now because we've seen it so much. Domain goes to the left and to the right. So it's -infinity to +infinity. And the range, last one, the range lowest y value is at -1. Highest y value is at infinity. So that is my domain and my range, analyzing all the key pieces of that quadratic function. Okay, next one. It says for the given function, find all those key pieces, -2 x minus 1 squared plus 8. So now we're going to go through and analyze this one. Remember, this is A, H, and K. Direction of opening. Because the negative is in the front, so A is negative, that tells me that my graph is going to open down. Remember, we said negative means that it flips over the x-axis, so my graph is going to open down because of the negative in the front. Next one, vertex. Remember, that's the H, K. My H is +1 because it's the opposite of what is on the inside. And then 8 because that's the K value. The x-intercept, we set y equal to 0. So I'm just going to set the entire function equal to 0. 0 equals -2x minus 1 squared plus 8. And go ahead and solve for x. Subtract 8 to both sides. So we get -8 equals -2, x minus 1 squared. Divide by -2 because I'm trying to get that x stuff all by itself. X minus 1 squared. Again, how do we undo something that's squared? Right, we take the square root. Square root of 4 is 2. Remember, it's plus and minus though because I took the square root of a negative, or of a number. X minus 1. Add 1 to both sides. 2 plus 1 is 3. And -2 plus 1 is -1. So those are my x-intercepts. Remember, write them as ordered pairs, 3, 0, and -1, 0. Those are my two x-intercepts. Let's go do the y-intercepts. The y-intercept, remember, that is where x equals 0. So I'm going to plug in a 0 into my equation for my x. Y equals -2, 0 minus 1 squared plus 8, and simplify. 0 minus 1 is -1 squared plus 8. -1 squared is 1. -2 times 1 is -2 plus 8 simplifies to 6. So that is my y-intercept. 0 was the x, 6 was the y that I found. Now I'm going to use all the information I was just found in my equation to go find what the graph looks like. So let's go draw a graph. Knowing that it is squared, we know this is a parabola. My vertex, we just said, was 1, 8. So here's 1, 2, 3, 4, 5, 6, 7, 8. 1, 8, right there. Our x-intercept was at 3, 0, right here, and negative 1, 0, right there, and an y-intercept of 0, 6, right here. Now I've plotted all the pieces. I know it's facing down because of the negative in the front, so I'm going to connect all the pieces together to make my parabola. Okay? And that's what our parabola looks like, the sketch of it. The axis of symmetry, remember, is x equals whatever your h value is, which is 1 in our case. The min or max, does this have a min or a max? Right, it's got a max because it's pointing down, so it's got a high point. And remember, the max is the y value of the vertex, which was at 8. So I have a max value of 8. Domain goes from negative infinity to positive infinity because it goes to the left and to the right. The range, how far low it drops? Well, I can see by my graph, it goes down to negative infinity. How far high it comes up is right there at the top at 8. So that is where my range goes, to 8 with a bracket. And that's analyzing the second function. Let's go do one more just to make sure we're good with analyzing these quadratic functions. Our equation is f of x equals negative 1/3 x minus 1 squared plus 1. Since you've seen me do a couple, I would pause the video now and see how many of these you could find on your own. And then play it back and see if your answer's right. Direction of opening. This is A, H, K, vertex form. Because there's a negative in the front, my graph opens down. There's that negative in the front. The vertex. Remember, it's the opposite of H, so it's positive 1, HK. X-intercept is where y equals 0, so I'm going to set the function equal to 0 and go solve for what x has to be. Okay, first I'm going to subtract 1 from both sides. So negative 1 equals negative 1/3 x minus 1 squared. Then divide by negative 1/3. 1 divided by 1/3 is positive 3. You can type that in the calculator if you need to. X minus 1 squared. Then to undo something that's squared, I'm going to take the square root. And I'll come up here to simplify it. We get plus or minus the square root of 3 because root 3 does not have a perfect square. So we're just going to leave it root 3. Equals x minus 1 and add 1 to both sides. So x equals plus or minus root 3 plus 1. That's our x-intercepts. So we have root 3 plus 1 comma 0. We also had a negative because we took a square root of negative root 3 plus 1 comma 0. Now let's go find the y-intercept. Remember, that's where x equals 0. So y equals negative 1/3, 0 minus 1 squared plus 1. And simplify. 0 minus 1 is negative 1 squared. Negative 1 squared is 1. Negative 1/3 times 1 is negative 1/3 plus 1 is 2/3. So that's my y-intercept. 0 was the x, 2/3 was the y. Now I'm going to use all those pieces, the vertex, the intercepts, knowing that it opens down, to go sketch the graph. Goes across. Now let's label the vertex. Starting at the top, the vertex is 1, 1. So here's my 1, 1. I have an x-intercept of root 3 plus 1. You can type that in the calculator, but you should get somewhere between 2 and 3. So here's 2, here's 3, so I'll just put my x somewhere between there. And the negative root 3 plus 1 is between 0 and negative 1. So there's the other x-intercept. You can type that in the calculator if you need to get the decimals. And then I have a y-intercept at 0, 2/3, which is right here between 0 and positive 1. Now I've got my pieces. I'm going to connect the dots together. I know that this graph is going down, so I know that it's going to swing on down here. And there's our parabola. The axis of symmetry, remember, is the vertical line that divides the graph down the middle. At x equals 1, because that was our h value. Does this have a min or a max? It's got a max because it's got a high point, and that is at the y value of 1 for our vertex. Domain, it opens to the left and to the right, so it's negative infinity to positive infinity. And the range, it drops down to negative infinity and comes up to a high point of positive 1 with a closed bracket. Remember, we use brackets and parentheses for domain and range. And that is the end of looking at quadratic functions in vertex form.